Welcome back. As I said earlier, in some cases you may not have to convert the water in milliliters to liters, and I just wanted to show you a problem where that is happening. So in this problem, you're asked to calculate the molarity, right? That's what you're asked to calculate. And we know that any compound that's not water is more likely your solute, because there's no better solvent in the world than water. Of course, when you get into organic chemistry, you will learn organic solvents, but for the most part, water is our solvent, right? And we write the definition of molarity. Again, you don't need to write it every single time, but I'm writing it because it's my job to teach you and help you understand it. So moles of solute over 1 liter of the solution. Okay, so that will be, well, we got to figure out each part separately, right? And I highly recommend, until you get really comfortable, I wouldn't just do them all in one step. And I can do it, but if you can do it, that's great. If not, keep it in parts like I do, right? So the first thing you have to figure out is the molar mass of the solute, which is, because we're only finding the moles for the solute, not for the solvent. So molar mass of solute, which in this case turns out to be MgCl2, right? And Mg in the periodic table is 24.3. So I'm just gonna do 24. And the Cl is 35.5, so 2 Cls would be 71. You can use the actual value in the periodic table. So you will have fractional values. I have whole numbers. Honestly, it makes absolutely no difference in the final answer. 95 grams over 1 mole. Keep in mind, each of this atomic mass unit is grams per mole. We've done that too many times. So when we add them, the unit should still be the same. And I always write it this way, like you've been seeing it, because it just helps with understanding. 95 grams over a mole. And the first step is we have to use the given information, which is 2.5 grams of MgCl2. That's the given information that always goes on the far top left cell, and the bottom is 1, because we don't have any information to put in there. And then obviously we know the molar mass is 95 grams over 1 mole, but we have a gram at the top, so the gram must go on the bottom. So the 95 grams goes at the top, the 1 mole goes in the 95 grams goes in the bottom, the 1 mole goes in the top, and then we cancel out the grams. We're left with moles. Right? So if you do the math, it'll be 2.5 over 95. It's about 0.026. I usually write 2 to 3 decimal places from whatever my calculator gives me. So 2 to 3 decimal places. Real numbers 263 moles. That's my solute. So this is what this is corresponding to. And in the bottom, 1 liter of the solution. Well, since this unit's already given in liter, you use it as it is. So we know the volume is 1.3 liters, right? So let's put it all together. So molarity equals, the top is 0.0263 moles. The bottom is 1.3 liters. You don't need to do any changes to it. And I bet you all wish, can you give us that as the entire exam? Well, very optimistic, but I'm going to have to say no. So 0.020 moles per liter, because that's what the unit's left with, or 0.020 uppercase M. Both are correct. But I recommend you use this often than this. This is only helpful if you're just writing a final answer. This is much more helpful to actually solve a problem. because we will take this information in a future video and do something else with it, okay, which you will see in the lab also down the road. But for now, I've told you, I walked you, I think two or three different kinds with the milliliters and one with the liter for the molarity. Okay. Now, let's go to the next concentration term, which is molality. Molality and molarity. They're two different things. We finished molarity, moving on to molality. Molality is, again, the same thing. The top part is the same, moles of solute. But the bottom is 1 kilogram of solvent. So it's kind of the same. And honestly, there's not much difference in terms of just the problems we've looked at. They look very similar, but you do have to understand the unit's not moles per liter, but it's moles per kilogram. Okay, that's important. So what if the question is, and we write the unit as moles per kilogram to the final answer, or lowercase m. Okay, that's all you have to know about molality. So what is the molality? Okay, molality of a solution. Still, we talk in terms of solution, but the way we do the problem mathematically is different. When 2.5 grams of sodium chloride is dissolved in say 500 milliliters of water. Okay. Right. So the top part is essentially the same. So you've got to figure out first the molar mass of sodium chloride. So that would be, sodium is 23. Again, I'm using just rounded up whole numbers. You can use the actual values in the periodic table. Cl is 35.5. So that would be 58.5 grams over 1 mole, right? So that means 2.5 grams of sodium chloride would be 2.5 grams of sodium chloride. Again, that's the given information that goes on the far top left cell. The bottom is a 1. And then for the next cell, you can just, because the molar mass is grams over mole, and we have to get rid of grams to get moles, so the 58.5 grams goes on the bottom, and the 1 mole goes on the top. So that will be 2.5 divided by 58.5. That will be 0.0427. I just always write at least three actual numbers past. If that's where the real number starts, and I usually write 3, at least 4 decimal total, 3 with the numbers. So that will be the moles. So we're done with the top part of the problem. The bottom is 1 kilogram. Okay. Again, we're making the assumption that the density of water doesn't change. Okay. So we're going to treat 500 mils as 500 grams. Okay. 500 grams of water. 500 mils written as 500 grams of water. How do we convert it to kilogram? Well, it's the same deal. Let me write it in a different color so you have the conversion somewhere sitting. So 1,000 gram is a kilogram. So 500 grams would be 500 by 1,000, which is 5 by 10, right? It will be 0.5, right? 0.5 kilograms. Got to convert it to kilograms. You can't just put 500 on the bottom. I have seen students do that, and they're going to get it wrong because they don't pay attention to the unit, which is in kilograms, not in grams. So now we know this information. We know this information. It's just time to tailor them together and stick them. So what does that mean? It means we got to go get our molality equals 0.0427 moles divided by 0.5 kg of water, which would be 0.0427 divided by 0.5. That in your calculator, and you get 0.0854 moles per kilogram, or 0.05854 lowercase m. Okay. Okay. And there is not really much in terms of variety for molality. That is pretty much the only way it can be asked. Of course, I can always give you 1.5 kg. In that case, you don't need to even do any conversion for the bottom portion of the formula. You just have to still do the grams to mole conversion for the top. All right, so I'm going to stop here, and then when I come back with the reminder video, I'm going to solve the remainder of the 2 concentration terms in one video, so we can keep the number of videos to the minimum. All right, so stay tuned.